Hello then, welcome to this workshop. My name is Valentine and I'll be your instructor. In this workshop, we'll be going through what is called machine learning with PySpark or big data machine learning with PySpark. This workshop primarily aims to help you be able to work with big data or lots of data when it comes to data analytics and Python. So let's get started. The structure that we're going to be undertaking for this workshop will be this one. We'll get started learning about the objectives or the learning outcomes. After that, we'll talk about what those concepts in relation to machine learning with PySpark are and why we would want to learn about them. Then we'll get into a practice session where we practice those concepts using the PySpark library. It's a library in Python that we can use for data analytics when it comes to working with lots of data. Then towards the very end, we'll just go through just the next steps. What should you do now once you have undertaken this learning experience? All right, so let's get started. By the end of today, we are expected to have achieved these learning outcomes. We should be able to outline the concept of distributed computing and its advantages in machine learning. So we should be able also to develop and apply machine learning models using PySpark's MLlib library. So this is a library in machine learning that we can use that's provided by PySpark that we can use to create machine learning models, whether it's for regression, classification use cases, or for clustering use cases, or for just different other tasks in data science or data analytics. Lastly, we should be able to evaluate the performance of our models, the models that we've created using Spark, using just evaluation metrics. It's also important to note that as part of the prerequisites for this workshop, the idea is that you have already done machine learning with Python using a library such as scikit-learn. So this workshop aims to develop your knowledge when it comes to using PySpark, as opposed to developing your knowledge as what regression, classification, or clustering entails. Our focus won't be largely on explaining the different concepts in relation to regression or classification. We've done that in the past in other workshops or in other learning experience, and we hope that if you are coming into this learning experience, you already have some idea and you've already implemented or created models using scikit-learn or other basic models still in the past. If you feel like, if you realize that this may not necessarily be the case, that you do not have that experience, we would highly advise that you go through those workshops, and they're available, readily available on our platform. So even on our channel, so you can just first of all, go through and fill in those gaps. Then once you're done, you can come in and now continue this workshop. It will feel much more natural that way and you won't be lost. But again, if you realize that you are sort of getting left behind in certain cases, feel free to pause the stream and rewind to just be able to just catch up and have some good understanding of the concepts that will be covered. All right, so what is machine learning with PySpark? So this refers to being able to create machine learning models and to use what are called algorithms to create those models, but now using the PySpark library. We won't be using the traditional machine learning library in Python. That's the scikit-learn library. But now in this case, we'll be using another alternative, which is this PySpark library. This library will provide us with algorithms, which will come in the form of classes that we can be able to instantiate, or we can create models out of that we later train on historical data. So think of machine learning with PySpark as more like just what you did with scikit-learn, but now you're just doing it with a different tool. We'll get to learn about different supervised learning algorithms and supervised learning algorithms that might come in handy in this process. And it's important to note that So yeah, I think something else to note, it's also important to mention that the idea of having libraries for machine learning, it's something that you might come across it in other cases, because PySpark is one of the many libraries. There are many libraries still in relation to Python. And yes, you have scikit-learn, which is the most basic one. Yes, you'll be introduced to PySpark. In some other cases, if you continue your learning journey, if you want to become maybe a machine learning engineer, you will also get to come across what is called TensorFlow, which is another library framework. It's just a collection of libraries that you can use for machine learning. If you also look into other contexts, you also find libraries which still implement the same basic concepts of, say, decision trees, the same concepts of logistic regression for that classification problems, etc. So here it's in this workshop, we're just going to be adding another toolkit, but again, your knowledge of what you have covered in the past will just actually remain constant. I would use that as the best word for that. So what PySpark does, this particular library, it leverages what is called Apache Spark, which is a big data tool that you can use for data analytics. Instead of using a tool like the basic tools that that's from pandas to scikit-learn, we can then instead use Apache Spark to perform big data processing, working with data that comes in the terabytes. But in many cases, it's important to note that the basic tools usually work. Pandas, scikit-learn, those ones, they work well. It's only that in certain cases where you are working with lots of data and you need to pre-process that data, and sometimes you might even need to just experiment. Then in such cases, you might decide then to use or try and implement those machine learning models using just Apache Spark. But the easiest way to do so without learning something else is another programming language, because Apache Spark is written in Java. Instead of learning Java, you can always use PySpark, which integrates with Python and gives you the advantage of what PySpark leverages behind the scenes. So it uses what are called RDDs, which are data structures that efficiently allow you to manipulate data. So with PySpark, you have that ability to leverage Apache Spark and perform create solutions that would be required for the use cases that you might have. The steps for performing machine learning still remain the same. Again, the only thing that you're going to be doing with regards to PySpark is just importing the libraries. Instead of importing scikit-learn, you just import now the PySpark models that you get to work with. Now, PySpark comes with what is called ML lib, which is actually what we are going to be using within PySpark to import the algorithms that we will need to create the models that we need. So the steps to performing machine learning would still remain the same. Initially, you would import the libraries that you need. At the very core of Python, you do not have PySpark. Sometimes we usually have something like scikit-learn. In many cases, if you're using maybe an environment that you've stored, that you have locally, could be maybe you have JupyterLab, you've installed it using maybe Anaconda. Normally those ones are provided, but when it comes to PySpark, you'd have to import it, to install it, then import it. Then you load and explore the data, the training data that you need. You perform data pre-processing. PySpark also provides us with just a few functions that ensure that the data that we are going to be working with is in a better format for the machine learning models. So we can also use PySpark for a few data pre-processing steps. Then after that, we build the machine learning models. Then we train and evaluate them, then we can use them to make predictions. And we'll go through a few of these algorithms that would normally come in handy. We won't go through all of them. There are tens of algorithms for machine learning models, for creation of machine learning models, but we'll just cover a few to just give you an idea of what that process might entail. Why again would we want to perform machine learning with PySpark? Again, a few reasons still remain the same from being able to perform machine learning with, not machine learning, but data analysis and data wrangling with PySpark. And we'll still cover, we'll just also talk about them. But one of the things that we would need, one of the reasons why we would want to use PySpark for machine learning would be it also offers a comprehensive set of machine learning algorithms that we can use for classification, regression, clustering, there's collaborative filtering, and quite a large number of machine learning use cases. So or related tasks that we can perform, we can use it to perform. And when it comes to big data, again, when you're working with lots of data, to be able to train your machine learning models, those techniques are still the same, but now they are in the context of now working with big data as opposed to working with a tool like scikit-learn. MLlib, again, also, which is part of PySpark, provides us with a set of functions or classes that we can use that allows us to be able to pre-process data, like ensure that the data is in the right format. So we can do what is called feature extraction. We can also be able to convert all the, say, for example, in a training data set, you normally have a feature set, which is just a collection of independent variables. You can use now, you can further prepare that data using the MLlib pipeline to be able to have data that is in the right shape for a model. And we'll be able also to cover that in a few. With PySpark, you're able to leverage Apache Spark's distributed computing capabilities in such a situation. Again, when you have large data sets, you can be able to efficiently handle that data. You're able also to integrate well with other big data tools. So if you would want to maybe even, again, pull some data from some other data source, big data source such as Hadoop, then you can also be able to integrate that without a lot of difficulty. You can also, you also have a friendly user API or set of classes that you can use to just perform just generally tasks related to machine learning. So just think of PySpark for machine learning, which is MLlib, which is the tool itself that we're going to use, MLlib, as more of like scikit-learn, but now for big data. All right. The techniques that we are going to be covering, so these are just well, we won't cover all these techniques, we'll just cover a few of them, but supervised learning will just compare like 3 to 4 different ones for classification and regression, and also cover just one for unsupervised learning, that's k-means clustering. But again, you can still import the classes, the respective classes. That's in Python, you have classes and objects, so you can import the classes that you need for principal component analysis, singular value decomposition, for all those other tasks that you might want to do. I mean, documentation is usually your best friend, so that is something that we can also do with the PySpark library for this particular use case. So at this particular point, you can go to the video description section and click on that practice resource, and you should end up to on this page, and click on the sample practice resource. And once you have clicked on the sample practice resource, you should end up in such a page, and you can now save a copy. So go to file, then save a copy of this notebook, and we can then use it for our work. If you're an Afterwork member, you can use the practice notebook, which I'm going to be using, by the way, for just ease of learning. So yeah, but it's the practice notebook, it's just the same as the sample notebook. All right. So once you have done that, once you've saved a copy and you've opened your copy, you can just run the first cells under prerequisites. I ran these ones because I knew they take time. It might take about 20-30 seconds. Just wanted to save time. So you can do the same thing. Then once, by the way, again, once you can always even pause this stream or the video so that you're able to do everything and then continue afterwards. So once you have done that, you also need this data set. So click on this link. It should open a new tab, then click on it again, and it's going to open a zip file that that it's going to download on your downloads folder. So the next thing that you need to do is to go to your downloads folder. So let me do that and extract the file that has been downloaded. So you need to extract it. It's called ML PySpark. So you won't be able to see what I'm doing on my screen. I haven't shared the entire screen. So I'm just going to extract it. And once I've extracted it, I've already extracted it. On the far left of your screen, so you should see this files icon. Click on that. And then I'm going to upload all the files by clicking on this icon. Upload to session storage. Then I'll just select the files that I'll go into the folder that I have extracted and select the files that I need. So you'll select all the files aside from the first folder. The first folder is Mac OS X, but what you need is just the CSV files. You can multi-select all of them by pressing Shift then down arrow. Once you click on one, just press Shift then down arrow. Then say open, and they should be downloaded on the far left. So you just say okay. And you should have those data sets that we need for this session. We won't be able to load them straight from a URL. The reason is there's no direct support for that. What we can still be able to load them from directly from a URL, not directly, indirectly. So we would have to use the requests library, but that is not, it's out of the scope of this workshop. So I did not see a need for going that way or including another library, and yet we are learning about this one. So yeah, so once we are done with that process, let's now go through supervised learning techniques. Again, pause the video, then do all of that. Import those data sets, and those are the ones that we're going to use. Yeah, and maybe you might find that there are many more data sets. The data sets could be that they are for just the different challenges, and the sample notebook doesn't have all the challenges. You'll note that as well. All right, regression techniques. Let's get started. Linear regression. It's a regression technique. So in regression, we would be creating a model that makes a prediction for a variable that's numerical in nature. So that's something to take into account. So starting off, we are going to import this data set. We want to create a model and train it on this house prices data. So yeah, so we would have actually also clicked, if you haven't followed this method, the other method would have been to click on this link, follow it, and download the file and upload it here one by one for each and every section. But that's a bit tedious. We thought just to provide just the zip file, zip folder at the very beginning. That way it's a bit easier for you to just navigate all of that. So yeah, so let's start a Spark session. So we'll start a Spark session by saying from PySpark import PySpark session. By the way, here I've already explained what you're doing here, importing pandas for manipulation, but we wouldn't. I don't even know why I even, okay, we don't even need pandas, by the way. We don't need pandas. I don't know why I even added that. I think it's just human nature in almost all the learning experiences that we have. Pandas is like the standard. But yeah, we're just importing PySpark. And then once we have done that, let's start a Spark session. I think if you've done data analysis as well as data wrangling workshops, then this is okay. Run this. So we started a Spark session and read our data. We also displayed, we said that we want to show the header, as well as also we want to ensure that the columns have the right data types. So that's why we say infer schema. Yeah, that would be equal to true. Then once we do that, we this is now going to create a Spark data frame, and then we use the show function to show just the first 5 records. If you don't specify 5, you'll get 20, the first 20 records. So this is our data set. So what we want is to create a model to predict price based on area, bedrooms, bathroom, year built, backyard size, garage capacity, stories, and neighborhood. So once we have done that, we can see that we have this column here that's categorical in nature. So we are going to encode it. So encoding just involves replacing the values within this categorical variable with a numerical representation. So it could be that suburban will be given 0 and urban will be given 1. So this is what we do here. We use the string indexer from PySpark to be able to perform that encoding technique. So we use it and specify that this is the input column that we want to, this is the column that we want to convert, and we set that to input call and output column. So we will have another one. We'll create a new column called neighborhood index that will contain our values. That will be the new values that will have will be representative of what suburban and urban will be. And we perform that encoding technique by what you see here, and we display now the new data frame that's encoded. So we should see one that has neighborhood index. So there should be an extra column. So on the far right, you can see neighborhood index. All right. And then we now, again, prepare our data into what, so when we're working with PySpark, we can set to have, we can simply, instead of just selecting the columns, the way we would do by just simply selecting using the select function directly, with PySpark, we use what is called a vector assembler that ensures that the features are in a vector format, and also just generally the features that we're going to be using for training are in a vector format that can be used by the models for just learning. So we use the vector assembler class, and we set the input columns, the ones that we will have for the independent variables, the features in our data set, and we specify the columns that we want, including neighborhood index. You should note that we don't include neighborhood in this case, and the output would be output features. Now would be the features that we're going to be able to use for training. So that's what we do here as well. We use the select function. I wouldn't really explain a whole lot because we've covered this in data analysis or with PySpark. There's a workshop on that, a prerequisite workshop on that. If you are follow-up after workshops, you should be on the same page as we are. So yeah, we display now the data in a vector format, the features as well as the price, the respective price. Once we have done that, we then can instantiate the regression algorithm that we'll use. But before we even use it, we set the training and the test data. So we split that, and we use random.split. So that comes from still the data, the data that we had here. 70% will be training data, and 30% would be test data. Then we use linear regression class to be able to specify the features as well as the target variable, the variable of interest. So we are going to train our linear regression based off that. And we do that, the training process, using the fit method. And it's going to get the training data. And we then evaluate how the linear regression model performed using the evaluate function. This actually feels a bit easier than scikit-learn. Then we just display the root mean square error as well as the R squared value. For root mean squared error, we normally would want a value closer to 0, sorry, not to 1. But again, usually would need to be maybe less than 10% of the average of the target variable. We could have printed that a few moments earlier, but we can also use the R squared value to also understand how a model performed. So we also R squared usually has values between 0 and 1, and we want it to be closer to 1. So yeah, so let's do this process and print out the evaluation metrics. So you can see this is our root mean square error. Then R squared value is 0.99, so 99%, which is okay. Then, which means now we are good to go. We have our model that performs well, fairly okay. We would still need to perform other evaluation metrics to just understand how create other evaluation values to just understand how the model performed. But now we then decide to predict a new record. We have already pre-processed the data that you see here. So like, for example, here we have a list of tuple, and you can see here that we have 8 area square feet. It's 8 represented by 1800. Then bedrooms 3, bathrooms 2, year built 1990, etc. So we create a Spark data frame using that data. Then we again use the assembler or the vector assembler to create now, to ensure to transform our input. And we again, once we have done that, we decide to use the model to make a prediction, and then we display the prediction. So if I run this, I would want to see the price, the new price that would be predicted, which would be 26,000. It's actually 269,771. That's the prediction by this machine learning model that we've created for this new data. And we can do that for just different cases. But yeah, so this is just a quick example of how you can be able to create a regression model. So you can also just play around with the records and see what happens. At this particular point, pause the video and then work on the challenge, implement what we have covered so far, and once you're done, we can continue. All right, moving on. Decision trees, again, we can also use decision trees as earlier. So here we're going to load a different data set. So in the first case, we worked with linear regression. Here we're going to use decision tree regressor, and we're going to use a different data set. We're also going to almost actually apply the same methods that we had earlier. But in our case, we are also going to, so here we are just performing encoding. And here we are formatting our data using the, transforming our data using the vector assembler. And we're also performing machine learning training. So we're also importing the decision tree regressor. And we're setting the features and the price to be used, also splitting our data and also training. So let's run that. So it's not as much, there isn't much difference. The only thing is that we are just using a different class to create our model, and then we just evaluate our model. Something to note, I had forgotten to actually stopped Spark session, so it releases the resources that would be used. So this is the root mean square error for such a case, and you can also decide to make a prediction. I haven't made a prediction here, but you can also do the same thing for the decision tree regressor, just for learning purposes. But if you don't, it's okay. The idea is just to see how you can also implement the same. And you'll note also that we are using a regression evaluator. You could have also used the approach that we used here. We just used the evaluate function or method from the model itself. This would have also been something, this is a different approach that we have used here. We just use it using the regression evaluator, setting the label column, or the target column, which is price, and also the predictions, and also using the metric name. And you can also use the R squared metric if you want as well. Pause the video and then work on the challenge. Random forests is another type of model that we can create. Still, it uses multiple decision trees to ensure that you have a model that is much more accurate. So let's load our data set, and here we're going again also to predict price, but now we have different feature sets. So transform that, perform encoding, then we convert our data to a vector format for our model. Then here we are importing the random forest regressor, just as we did for decision tree regressor and linear regressor, regression regressor. And we can, also see the predictions. So we can also compare, like for price, initially for the test data, this was the price, but the model made this prediction. The same case here, the same case here. There's some sort of error there's actually error. So we also print out the root mean squared as well as the R squared error. This is how you're able to specify the metric that you want to preview. And this is what you can see as the final output. R squared closer to 1 it's okay. Can also check on this. Can compare this with the average. We haven't done that, but we could always do the same thing. And we perform prediction with new data. And we get 486, and voila, that's it. Pause the video and then work on the challenge for linear for a random forest. All right, so we're done with regression problems. You can always have a look at the documentation for the rest of the algorithms. You might find some others that are quite that you might find there. And also, it's also important to note, while you're also opting to think about which library to use for big data, you might realize maybe the implementation of a certain algorithm, a specific one, I'm not sure which one that could be, that you might find in scikit-learn, maybe it hasn't been implemented with PySpark. Maybe sometimes that could be the case because there aren't many use cases, but you might find maybe some independent data scientist somewhere who has done the same thing. They've implemented that, but they haven't, the logic hasn't been, the code hasn't been pushed to PySpark, but you could always also consider such cases, but you'd also need them to review their code, understand how it works before now using it for production, and to make just useful decisions about what you're doing. But yeah, let's continue. Classification techniques. So we're going to cover just 3: logistic, naive Bayes, and support vector classification or classifier. So let's go for logistic regression. So we download this data set. For this case, for classification, we want our target variable, which is chan, it's categorical in nature, so it has 2 values. So yeah, so the also approach that we're going to use here for encoding will be slightly different from probably what we have used earlier. It's just an efficient way of being able to do what we have done earlier. So instead of just listing out all the columns that you have, you can decide to use the approach that we have here. We create what is called a pipeline, and we define that in this pipeline we want to, we have this is the indexes is the process that we want to undertake in the pipeline, and this particular pipeline will have this particular operation. So string indexer, which you have used in the past in the previous section to encode, we set the values that we want, which are gender, education, marital status, and chan. We want to encode them, and we set the output column such that if it's gender, it will have an index. So it will be gender index. That's the new column that we want. Education index, just like the way we had in the past. The same case with marital status and chan. So we'll have 4 new columns which are categorical in nature. So instead of just listing out, the gender index, education index, that would work. So so that's what we do. And if we run this, we should be able to get the transformed data frame that we have at the very end. You can see gender index, education index. I don't know whether you're able to see. Yes, should be able to see now. Gender index, education index, and marital status index and churn index. And that's what we're going to use for our analysis. So we used, again, the vector assembler class, and we specify the features that we want to use to work with. I think this is now pretty common right now. It's not that much different from what we've done in a few. So once we've done that, we also do now the machine learning training. We import the logistic regression, the class itself. But logistic regression is a classifier, so we can use it for binary classification problems. We split the data set 70-30 and also set the seed. By the way, the same case, we could have also done the same thing. I did not include that for the previous cases, but it's important to set the seed to just ensure that you have the same output. You might also notice that you're getting the same, you've not been getting the same output as before. So that could have been a reason, because you might find that I'm getting maybe an accuracy score different than yours. It's because the records for the 70% and 30% are not the same as mine. So you need to set the seed parameter with that. Then logistic regression, we set the feature columns, we set features, the ones that we're going to use, as well as the target, and we train. And so we also just show some output of how it was able to make the predictions, and also its probability. With logistic regression, you can also be able to display the probability. So this is what we are able to see. And then we can display now the accuracy, so which we can also do the same. We can display also different accuracy metrics, not just not accuracy metrics, evaluation metrics, not just the one that you see here, but you can do the same thing. And here we're just using binary classification classifier, but there's also, you can also, not multi-class, we're using multi-class classification evaluator, but you can also use there's also a binary one. And lastly, we perform some prediction and and display that. All right. Pause the video and then work on the challenge. Naive Bayes is another type of model that we can create, especially when we have lots of text data. But in this case, we're just going to be using it for just learning, not so much of assuming we had lots of text data. But we have a few, which I think it's through gender, location, payment method, etc. But yeah, so we now encode the values. So once we have done that, here we are also just using a different method. We're not using the pipeline. We're just using a different method for our case, and we can be able to also display. If you want, you can also just display what's performed here, but it's just going to be performing an encoding technique that we have been doing earlier. And here by the way, what we're doing here, it's just using a list comprehension. I not mentioned that in Python. So once we've done that, we also use the vector assembler to set the data that we have in a vector format. Then we import Naive Bayes and we set the features and target, split our data, train our data, and then make predictions. Then once we've done that, we can display the accuracy score, and we use it to make a prediction. This is the prediction. And here we just hard coding the values than what we did before. All right, but by the way, prediction of 1 just means that churn index would be predicted as 1. So in our case, we would end up having, I think it's either yes or no. Sure, I'd have to print out. Let me see if I can print out df .show 5. So we're just printing out that okay, index source. let's see what's, oh, it's because the reason why I've gotten that error, it's because I stopped my Spark session. So I would need to rerun this again and again. If you get that error, just know that you need to rerun the code so that you start a Spark session. So here, a value of 1 for chan index would be what we have here. So chan index, that's the first record. That's the one, would be yes. So no would be 0. So the prediction here would be a yes, that this particular customer with these details would chan. You can play around with the values and see what happens. Pause the video and then work on the challenge. All right, support vector classification. So this is another type of, how should I put it? It's another model that you can use it, and it works by finding a hyperplane that best separates the classes. And we would normally work with this data or this type of algorithm when we want to. We can work with it actually anytime, just to also figure out how it performs. But normally it performs really well when there's a large number of variables, so in a higher dimensional space. So, and again, when the data set is not that large, when it's small. So let's load this data set that we're going to use again for training. And this is another way we can use for encoding. We can just list out the different string indexes and perform encoding. Just different methods. Thought to just incorporate that. And if you just scroll to the right, you'll find the different columns that we have. Then we prepare data set. Then we use the linear SVC. So this will implement a support vector classifier that uses the linear kernel. So when it comes to SVC or support vector classifiers, there are different kernels, but then we can use this one we can decide to use a linear for this case. But again, you can always consider the documentation to just see the different classes that you have available for SVC. Yeah, so we train our model and then we check on its accuracy right here. And then again, we can see it's 91. And then we preview we make a prediction. So, and we can see the prediction here, it's a 1. All right, pause the video and then work on the challenge. All right, moving on, unsupervised learning. We're only going to cover k-means clustering, but there are other techniques that you can cover. This is just to get you started with this library. So k-means, when we are performing k-means clustering, our goal is to have our data sets be clustered or to be put into different groups. So here we are going to run this and be able to see how our data set looks like. So we have this data set. It contains, okay, it's not a customer chan data set. It's a data set that contains networks data. I think the name it's a bit different, but yeah, it contains network data. So you can just see what's happening with just different devices, servers. It's actually servers data, not networks data, servers data, and the location. Then we can decide to encode those variables. So that's what we're doing here. I think we are already accustomed to this. Then we could display them. By the way, we could display the f indexed show. We only just want to show the first 5. And we can see the index data. We are performing encoding because normally algorithms or models that we create can take data that's that has some numerical nature. Then we create our vectors for the features that we have. Then we instantiate our k-means algorithm, and we set that these are the features that we want to use to perform k-means clustering. We also want 3 different groups. So we'll have our our columns separated into different groups. So let's run this. And then we can display the prediction as well as also the Silhouette score, which is an evaluation score. It just tells us how our clustering happened in terms and in what way we wanted, and we can always compare the Silhouette score of whether of, let's say, 3 clusters. So the value of K here could always change and see our Silhouette score. Normally we would want a Silhouette score that's closer to 1. Yeah, so let's run this and we will get, say, a Silhouette score of 0.56, but this is now the prediction. These are the different classes. So these groups, these servers, and the ones that you are seeing here are much more similar. And we could always filter those records and then do some further analysis, like data analysis on them. Same case with zeros. These zeros, 12 and 18, seem like, they're much more similar to each other. They're outliers in their sense. The same case with 8 and 9. So we can do the same thing, but here we have Silhouette score of 0.56. Normally, Silhouette score ranges from -1 to +1. So what we will need is something that's closer to 1. If we change maybe this to 2, we can change and see what happens. We have 0.56. So let's change that. We've changed it to 2, and let's see whether this actually 0.74 is actually, it means that clusters are much more better than 0.5. So the idea is that you have a Silhouette score that's closer to 1. It means that you have now partitioned your data set in the more natural way. So what if K equals to 4? Let's see what happens. Normally we would print out for all the values, but here we're just doing the hard coding bit. Let's see what happens. 0.5. I think 2 is the one that works. 2 is the most optimal one. So we can always go to 2, which means that there are more of 2 distinct clusters. So these would be, that would be the best number of groups that we can use for this data set. And so assuming that we have this model that we have here, we might want to use it maybe to predict a new record based on what it has learned from based on the patterns that it has gotten from the actual records. Not really, yes. So it's not really going to be learning. It's actually going to be grouping this new record with either the zeros or the ones. And so let's make that prediction. All right, and that's it. That's it. Then you can now work on the challenge. So at this particular point, pause the video, work on the challenge, and then we can finalize on what's next after now learning about how to work with PySpark. Okay, so I hope you've already gone through the challenges. So in terms of the next steps, what would we recommend? We would recommend projects that you can be able to implement using the concepts that you have learned so far. More specifically, ones in relation, maybe one on regression, one on classification, one on clustering. The idea is that you will be you have acquired those skills. By doing, you'll have acquired those skills that you need to implement or to use to work on solutions that still relate to machine learning with PySpark. But again, this is one of those skills that you may not necessarily use in many contexts, because not many organizations use a lot of data, but it's important to have an understanding what such a tool can have, just in case maybe you are scaling within your organization. And it's important just to know what a tool has in store for you. That way, in situations where you might need to implement a solution using that skill, with regards to this particular technology that relates to big data, then you're able to So projects, we'll be posting some few projects on our After Work platform, just some quick projects, walkthroughs. You can always consider implementing those projects. It will just be allow you to just see how you can be able to create a solution that end users can also interact with. Aside from that, the next thing, once you've gotten to learn about machine learning with PySpark, our next recommendation would be to now specifically move towards maybe a certain area of machine learning that you might want to look into. So after machine learning with PySpark, maybe you haven't learned how to visualize data from such a data that comes from such a tool, then you can also consider doing that. Or how PySpark integrates with maybe other data sources to work with maybe just real-time data, and some other concepts, advanced concepts that we haven't learned so far. So yeah, so that's it. I hope you were able to learn a lot from this session. You found it valuable. If you did, please leave a thumbs up so that we'll be able to know. It's like a way of just telling us keep on doing what you're doing. It's part of feedback. Sometimes when you see a video with just few likes, you're like, okay, people are not really much more interested in that. They would rather probably learn about something that has more of likes. But if you did love the experience, give it a thumbs up. And if you'd want to be informed when we post such future courses or even just projects in the relation of the same, be sure to subscribe, and see you in the next learning experience. All the best in your learning journey. Bye-bye.